Hello guys, this is CodeNCode and this is 8th lecture of Java Design Pattern series. In this lecture, we are going to learn one of the structural design patterns, that is a facade pattern. Right? It is very easy to implement and also just as easy to understand. So let's go ahead and see what it is about and how do we implement it. All right. So, so the facade pattern, by definition, it is a pattern, of course, structural design pattern that provides a simplified interface to a complex system of classes, libraries, or frameworks. Important thing is it provides a simplified interface. That is very important. That is the whole idea of facade pattern, right? It is used to create a higher level of interface that makes subsystem easier to use by hiding the complexity. Again, there are a lot of subsystems. It hides their complexities, how they work, what they do behind the scenes. It just provides you a simplified interface to do certain work, right? We'll see that in detail. This pattern is particularly useful when you're working with a large system of libraries where the underlying implementation is intricate and not necessary for the client to understand. Important thing. So if you have multiple subsystems and the understanding of the working is not necessary for the client. The client just wants to have a simple interface to do certain work, right? What it does behind the scene, the library, the class that you have written, or the framework, the client is not interested in that, right? In that case, you can use facade pattern. And also, I'll explain that in detail in here. For example, let's suppose we are building some library or framework to implement the banking system, right? So let's say we have built account service, right? There are multiple service, or you can call subsystems. So I have account service that does the job of taking care of accounts, like creating an account, updating an account, saving the address, updating the address, things like that, right? So we have account service. We have loan service that take care of the loan, like creating a loan, right, for a particular user, taking care of the EMIs, interest rates, right, GST and all things like that. So loan service will take care of that. Then we have transaction service. So all of the transactions will be taken care by the transaction service, right? Like ATM withdrawal, or you want to perform certain transaction from your account to someone else's, IMPS XYZ transaction. So those things will be taken care by the transaction service, right? Now we have these three services. As of now, these three, just to keep this example simple, we have these three services or subsystem, you can call it, right? If the client want to implement the features like ATM withdrawal, right, opening a loan, closing a loan, paying an EMI to a loan, right, creating an account, opening a new account, savings or current account, or updating an address of a current account holder, right, things like that. If the client want to do all of these things, they have to have all of these system to themselves, because we haven't provided as of now all of these features are provided by different subsystems. So client will have to have all of these things. The client will have account service, loan service, and transaction service. Transaction, I think I have added C twice. Yes, just remember that. So client need to have all of these to themselves, right? And now take an example of authentication service also. So before you do any kind of transaction, ATM withdrawal, you need to be authenticated also. So add authentication service also, right? So the client need to have 4 services in just this example. So before you perform an ATM withdrawal, the client need to perform authentication using authentication service. Once the authentication is successful, then it will proceed with the transaction service, perform the withdrawal, and update your account, right? All of this, the client need to do that. All of this complexity, the client needs to handle that. Do this, do that before doing that. So all of the steps, client needs to handle that. All of the exception, client needs to handle that. Everything, right? So as of now, the system is quite complex, and client don't even want to do that, right? If I'm building an application where I just want to, let's say I'm building a software for to install it in an ATM, right, so that I can perform ATM withdrawal, right? So I have to have a lot of subsystem with me. I don't want all that. I just want a simple interface so that I can call a single function and things are done. Behind the scene, I'm fine with that, right? I just make sure that the interface that is being provided to me takes care of the authentication and all everything, right? So I don't want to handle all of those complexities. That is exactly what facade pattern does. So what it does, it provides you a simplified interface. So account service, loan service, and transaction service, you can provide a facade. We are calling it bank service facade. You don't have to name it that. You can call it bank service application, right? And now this takes care of all of the things. So bank service facade will have account service, loan service, and transaction service, and it will simply provide you an interface, list of functions you can call. Now if I want to perform a transaction, I'll simply call a single function, bank service dot perform transaction from account to account amount, right? And then transaction will happen, right? So and all of the things like authentication and all are being done behind the scene, and the one responsible for performing the authentication and necessary steps before performing an actual transaction will be taken care by the bank service. Right, so you see, now your client only depends on a single class, not a lot of subsystems, a single class, single interface, right? So what it does, the facade patterns makes your it makes the services quite simplified to be accessible, right? That's what it does. So instead of having multiple subsystem in the client, you only have a single facade or entry point or interface, whatever you would like to call it, and then you can directly utilize that. All of the things will be taken care by the facade or the application that you are providing, right? So yeah, this is your facade pattern. So if you look at it, my bad, if you look at it, so components will be, of course, the facade, the application that you are building. You can call it application, facade, interface, whatever you like to call it. So this is the interface that will be provided to the client, and this will take care of all of the subsystem. So it will talk to all of the subsystem and will implement the function that are required by the client, right? So this is your facade. Then we have subsystem, of course, different subsystem or services which provide different things, different business logic, right? And then we have client. Whichever system is using those services is your client, right? So as simple as that. Now, why do we use it? What are the benefits of facade? As we have discussed already, some of the part you already understand. First of all, it simplifies the complexity. Of course, now client don't have to deal with a lot of subsystem, don't have to take care of the complexities in performing certain actions, right? Like authentication and all, logging and all, right? Client don't have to do that. Facade will take care of that. So it simplifies the complexity, decouples the client from the system, very important thing. So now subsystems are decoupled from the client. Client doesn't have subsystem, it only has the facade. That means you can build client and facade separately, right? As they are decoupled. So improves maintainability. Of course, you can keep on building clients and subsystem separately. So changes to the subsystem can be isolated within the facade, of course, and reduces the impact on the client code, right? And then, of course, promotes reusability. You have a facade, you can use it anywhere you want. Whatever client wants to use this subsystem, you can directly provide the client. So it promotes a reusability. Now, what is the issue with the facade pattern? The issue with the facade pattern is that there is something called a God object, right? You can Google and learn more about it. So when a class or tries to do a lot of things itself, it is called a God object, and it has issues with it, right? As you know, in the solid principle, we have single responsibility principle. If you take a class and give a lot of responsibilities to it, it will create a lot of issues, maintainability and all, right? Code changes and all, debugging and all. So with facade pattern comes an issue called God object, right? So you can go ahead and learn about it more. So your facade shouldn't try to do a lot of things, right? When you are building a facade, you should restrict its parameter so that it doesn't go out of hand, right? It should be logical, and only it should be implemented in such a way that fulfills the need. It shouldn't do a lot of things, only the required, right? So yeah, that is the issue with the facade pattern. So let's go ahead and implement also facade pattern in Java. Alright, so let's go ahead and implement the facade pattern. Alright, so let's say I wanted to build a database application, right? So a database does a lot of things, and it has a lot of subsystems. For example, to execute queries, it has query engine to log things, right? It has loggers, of course. To save the data, it has storage, right? So a lot of things are there in the database. And as we know that the client isn't concerned with all of these things, right? So database should take care of all of these subsystems. As a client, I don't want to take care of the logging things, executing queries myself, and taking care of the storage. All of these things should be provided by the database application itself. So this here is the facade, and let's say I have a database interface which provides create database, drop database, create table, drop table, insert into table, things like that. Basically the functionalities that I want from a database, and this is one of its implementations, which is database application, which is in our case the facade. Right now a facade need to interact with a lot of things like the logger to log things. When you are going to create a table, drop a table, insert data into the table, it will log details, right? And logging is actually very very important. If you are learning high level design, you would learn that the database has loggers which will help them. One of the logger is a write ahead log, right? So it will log things, right, whatever it is doing, and that write ahead log helps database to recover from a crash, or if unexpected things happen, right? So those logs are very very important. You can learn about write ahead log, or if you are following the um, uh, master slave architecture in the database, right? There is one master, multiple slaves. So and writes only happen to the master object, master database, right? So it maintains a write ahead log, and other databases, the slave one, read the write ahead log and then replicate the same changes that were made in the master database, right? So it is very important. So we have a logger, we have query engine that executes the query, and then we have storage, right? So database application, that is your facade, needs to interact with all of these: the logger, the storage engine, and the query engine, right? So logger is simple. As of now we have defined it. Log, it only logs things, right? So it logs what level, what is the level of the log: info, debug, critical, right? And then the message, right? So level we have defined as in enum, debug, info 1, and critical. So it takes the level and the message it logs. So as of now we only have console logger. It logs onto the console, right? You can define multiple implementation, like file logger, right, disk logger, whatever you would like to implement. As of now we have console logger, it logs onto the console. Then we have query engine, simple class I have defined as of now. We are not going into the details of the implementation. So it only does the job of execution. It simply prints executing this query, right? Then we have storage. So we have storage and an interface that provides a method store data. You can provide multiple implementation of it. We have defined this implementation, storage engine. Takes the data, simply prints that is storing this data, right? So the database will interact with all of these. So basically create database, right? So first of all you need to create a database. Inside the database you can create multiple tables. Provide the database table name, database name. Then we can, using the logger, we can log logging in level is info, and then creating database this and that, right? And then query engine will execute the query, right? Same way drop table, same way create table, and same way drop table. Create database, drop database, create table, and drop table. So here while dropping the databases, the logging level is critical. You want to insert something into the database, so logger will log that we are going to insert into this table, right? And then query executor will execute the query, and then storage engine will store the values there, right? So you see there are so many things. Logger provides certain functionalities, query engine provides certain functionalities, same goes for the storage engine, right? As a client in the main, I don't want to deal with all of these. So what I'm doing here, I'm providing database facade, right? And now instead of interacting with all of these, I only need to interact with the facade. So I can create a database is equals to new database application, right? Now I have the facade. Now I can go ahead and database dot create database. Let's create users, right? And then once I have that, I can create, not the password, I can create table inside of it. Let's call orders. So we have users, and inside the users we have orders. We have created a database and we have created a table. As of now you can see that we are not passing anywhere the name of the table database, and we are simply creating a table. Absolutely right. As I said, I'm just showing you how you can implement the facade pattern. We are not going much into the details of the implementation of each of these logger engine and basically the subsystem, right? So I've created a database, created a table. Now what I can do, database dot save insert into table, right? So table name is orders. Inside the orders, I'm going to save an order, right? And if you look at it, it requires a map. So basically key value pairs. The order ID is this and XYZ. So what you can do, map.off, you can provide key value pairs here. So key would be let's say ID, value is 1 2 3 4, so order ID is this one. Then you can say let's say status active, status, yeah, this is an order, let's call it delivered, right? So if I execute it, you see here so on logging level info, creating database users, right? And executing query or creating database users, done. And then on the logging level info, creating table orders, and the query executed is this one, creating table if not exist orders, right? And then of course on info, again executing this query, insert into table orders, values, status is equals to table delivered, and ID is equals to this one. So and of course this log is from storage engine. So as you can see, to perform all of these operations, I have a simple interface of which I can call certain functions. We could have had the authentication system also there, right? We could have had connection manager also there, right? So you create a connection with a database, execute the query, close the connection, and then the things are done, right? Or you can have connection pool also there, right? So there are so many subsystems. If we do not provide the facade or the entry point to our application, which is a simplified entry point, dealing with all of these operations by the client may lead to certain issues, one of which is complexity, other which is bugs and all, right? Because multiple clients will implement it different ways. That should not happen, right? So that's why it is important for you to provide, in many situations it is important for you to provide the facade of it, right? And that's why we have created a facade application. So yeah, so when do you use facade application? You have multiple subsystem details of which exposing to the client is not necessary, and you want to provide a simplified interface. That is the time when you think about the facade. And while implementing it, keep in mind that don't make it God object, right? So don't make your facade application, facade class, do a lot of things, right? So yeah, this is how you implement your facade pattern. All right, so yeah, this is it for this lecture. Thank you guys for watching, and till the next video drop, keep coding. Thank you.